Okay, welcome back. And what we're going to look at in this video very quickly is an idea which, when I learned about it many years ago, kind of totally blew my mind. And that's the idea of lipids in membranes being organized into structures called microdomains, and also known as lipid rafts as well. So you may have the preconception that membranes are these homogeneous mixtures of lipids and proteins, and things move around, and that's partly correct and it's partly completely wrong. There is this model where you have a fluid bilayer of lipids moving and diffusing laterally and rotating, spinning, and to some very infrequent event flipping back and forth across the membrane. But membrane lipids aren't distributed homogeneously throughout the membrane. So they are not homogeneous, freely mixing structures. Membranes are ordered structures, and they're ordered through dynamic microdomains called lipid rafts. Now, most cellular processes that involve membranes are completely dependent on the structural complexes that you see arising due to the association of specific lipids and proteins into these structures called lipid rafts. Probably the most common form, lipid rafts contain a type of membrane lipid called a sphingolipid. We'll come back to sphingolipids later, but they are basically built like a regular phospholipid, except rather than using glycerol, they use a molecule called sphingosine, and then they have fatty acids attached to the sphingosine. So those are sphingolipids. We'll come back to them. So lipid rafts often contain sphingolipids and a lot of cholesterol. And these sphingolipids and cholesterol enrich into these domains in the membrane of about 25 to 100 nanometers, and those domains can then actually move themselves independently of other domains and other lipids that are found in the membrane. So unfortunately, your book doesn't do a good job of talking about these, so I've got another piece of art that I've borrowed from Nature Reviews article in Nature Reviews Neuroscience, just to give you a little idea of these kinds of structures. We can kind of talk about two types of lipid raft or microdomain. There's a structure called a caveola, and that's showing up here in the top left. This is like a flask-like structure that forms on the membranes, on the cell surface, on the membrane, and that's like a little imagination of the pocket, and that's often due to the certain types of lipids that you find in the raft producing a curvature in the membrane. The other type of lipid raft is a planar lipid raft, and is what you see, or is what the artist is trying to show here, is that certain membrane proteins can associate into these lipid rafts while others will be excluded from them. So they give these domains of membrane specialization, and you see that a little bit over here too. The N2 is meant to be showing a neurotransmitter, because this was an article that was in a neuroscience review paper journal. So one of the big roles of these lipid rafts is believed to be in the role of signaling, and particularly cell signal reception in cell signaling. And so these rafts are believed to organize specific proteins into these regions of signal reception to regulate signaling processes inside the cell. And there are two kind of schools of thought, 2,000 models about how we think this can happen. On the left here is what we have is the idea that lipid rafts can organize certain proteins involved in signaling processes. So, you know, we have a transmembrane, possibly a G protein coupled receptor that's been localized to the lipid raft, and then some other proteins are involved in the signaling transduction part of the process of also localized to the membrane, to the lipid raft. So the question is, what's the point of that? Why bother doing this? When you bring things together into discrete regions or domains, processes can occur much more efficiently. You are increasing the local concentration. If you think back to our discussion on enzymes, one of the things you do to make rates of reactions increase is you locally concentrate the molecules that have to interact, the enzymes and the substrates. And you can do that for signaling processes as well. If you bring all the molecules together, then you will get the signal transduction process occurring much faster. We can also think about a model on the right, the bottom here, where we actually use these lipid rafts to dampen the signaling processes, where we use them to exclude certain proteins from the domain, and therefore lower the rates of signal transduction. So that's that's a real quick introduction to lipid rafts. These are going to come up again in several places, so we don't just talk about them all in one place. They'll come up where they're relevant, and we'll talk about them throughout the course of this kind of 2-chapter module. I'll see you next time. We're going to start looking at the lipids themselves.